The intermediate value theorem is another theorem that sounds rather confusing, but it's a rather easy point. I'll let you read it really quickly. Now here you go. If f of x is a polynomial and a is less than b, let's draw a number line, and let's have a, and let's have b on it. And f of a and f of b have opposite signs. Let's let f of a be negative, and let's let f of b be positive. Well, this is a polynomial function, which means it's continuous, so it's going to have to go through these 2 points somehow. It says, then f of x, the function, has at least one zero in the interval between a and b. In other words, the graph is going to have to cross through the x-axis to go from a negative number up to a positive number. Okay, now, there's lots of applications of this. Let's pretend you wake up in the morning and the temperature is 54 degrees outside. And you know that the daytime high is going to be 80 degrees outside. Wouldn't it stand to reason that at some point during the day it's going to cross through and at some point of the day it will be 70 degrees? We can tell that there will be this intermediate value that will be taken on between 54 and 80 degrees. Kind of the same idea right here. This is known as an existence theorem. It doesn't tell you where this x-intercept will be, but we know that there will be one of them because you can't go from the negatives to the positives without crossing through 0. Now, they want us to use the intermediate value theorem to determine whether we can guarantee that a 0 will exist on several intervals. What I've done here is I have typed in this equation into my graphing calculator, and I'm going to go and look at my table of values here, and these will be points on the curve which I'm going to draw out or write out for you. So here's my XY chart, and I really want to know what happens at x values 1, 2, 3, 4, and 5. The y values will be 12, 5, -4, -3, and 20. And if you want, you can find all those values by substituting each in individually. Now the first question is, will there be a 0 on the interval from 1 to 2? Well, notice how at x equals 1 we have a positive function value, and at 2 we have a positive function value. It's positive in both places, so no, there's no guarantee on that interval. But between 2 and 3, it's going from positive to negative, and so somewhere between 2 and 3 it's going to have to cross through and have a 0 value. So yes, we are guaranteed to have a 0 on that interval. From 3 to 4, there's no guarantee at all. We don't know whether there will be a 0 on that interval. But on the interval from 4 to 5, going from negative to positive, we do have a guarantee that there will be a 0 on that interval. That does not tell us what the 0 will be. It just guarantees the existence of a 0 or x-intercept on that interval.